So let's take a look at some of these problems that you had for the worksheet, okay? And try to recognize as many triplets and specials that we can, 30, 60, 90, 45, 45, 90, whatever we can recognize you want to do. So this is obviously a 3, 4, 5. This is a 5, 12, 13, okay? This is a 9, 12, 15, okay? This is an 8, 15, 17. This is a 7, 24, 25. Okay, you want to check on that one. This is a 5, 12, 13. Recognize that right away. Okay. This is, you have to go through and do the Pythagorean theorem on this. So it would be 64 minus 36, which would be x squared. So 64 minus 36, I guess, is what, 28. So this is a square root of 28, which is what x is, which is, of course, 4 and 7, so it's 2 root 7. This is a 3, 4, 5 multiple, so this would be radical 5. This is a, you have to go through Pythagoras. Go ahead, set it up, and 12 squared is equal to 10 squared plus x squared. Okay. This should be recognized as a 30, 60, 90 because one side's half the hypotenuse, so this would be 10 root 3. This is 9, 12, 15. You have to go through Pythagoras here, so that would be the square root of what? 100 minus 49, so that would be the square root of 51. All right, that's the front page. This is a 45, 45, 90 because it's two sides are equal, so that's equal to 5 root 2. That's equal to 5 root 2. This is a 45, 45, 90, so it's 8 root 8. I'm sorry, 16. That's 16 and 16. This is 10, 10, 10 root 2. All right. This is a 45, 45, 90, so it's 8, 8, and 8 root 2. This is a 45, 45, 90, so it's 15, 15, and 15 root 2. This is a 45, 45, 90 because the sides are the same, so they're 12. It's because this is 12 to the root of 2, having the hypotenuse divide by 2, root 2 to get the leg. So there you have it. Okay. This is should be recognized as that special combination 2. This is going to be 9 root 2, 6, 6, and 6 root 2, 45, 45. So this would be, this side is 20 divided by root 2, which rationalizes root 2 over root 2. So that's 10 root 2. That's the missing side there. Okay. 12, 12, and 12 root 2. 6 and 6 root 2 means that's going to be 6. This should be recognized as a 45, 45, 90. That's going to be 18 to the root of 2. Okay. So we'd have to go through Pythagoras on this one. So it's x is equal to 10 squared. That's x squared is equal to 10 squared plus 2 root 3 squared. Now remember, 2 root 3 squared is 4 times 3, so that's 12. So x is going to equal the square root of 112. Okay. If this is half of that, that means that's half of that, which means this is a 30, 60, 90. There's, so this is 14 root 3. This is a 30, 60, 90, okay? So this should be equal to 7, okay? Because the side opposite the one side is 60. That's a 60 because that is half of that side times the root of 3 makes it a 30, 60, 90. This is a 30, 60, 90. The y is the side opposite 30, so that's 50. Half the hypotenuse, and this is 50 root 3. This is 30, 60, 90. So here, the short side is 20, the hypotenuse is twice that, 40, and the long side is 20 the root of 3. Okay. Here is a 30, 60, 90. Here is the long side, which is opposite to 60, which is the root of 3 times the short side, so that makes that 9, and that makes that 18. All right. It's a 30, 60, 90 here. It's a 30, 48. So opposite to 30 is half that, 24, and then 24 the root of 3 for the missing side over here. This is a 30, 60, 90. Here's your 30. Okay, long side is 10 root of 3, so that makes this side equal 10, and this is then for 10, 10 double, which of course is 20. Okay, here is a 30, 60, 90 again. Opposite to 30 is 12, so the hypotenuse is double that, and this side is 12 the root of 3, so it's the short side times the root of 3. Okay. Alright, this is 30, 60, 90 because this is half of the hypotenuse. Half the hypotenuse is opposite to 30. Okay, so this is the 60, which makes x 24 the root of 3. 24 the root of 3. Okay, here's a 30, 60, 90. The arrangement 12 the root of 3, that makes this 24. Okay. This is just going to go through the motion, so it's 5 squared, x squared is equal to, what, 5, root of 5 squared, which is 5, plus root of 15 squared, which is 15. So x is equal to the square root of 20, which is 2 root 5. Okay, about a dozen problems left to go. This is a 30, 60, 90. Opposite to 30 is half of the hypotenuse, so that's half of that, which is 6 root 3. And the long side is the short side times root 3. So 6 root 3 times root 3 is equal to 18. All right, this is a 30, 60, 90. The hypotenuse is 20 the root of 3. The short side, which is over here, y, is half of that, so that's 10 root 3. The long side is the short side times root 3, so it's 10 root 3 times root 3, which is 10 times 3, or 30. Okay, 30, 60, 90. The long side given, okay, is 5 root 3, which is makes this 5 and this 10. Okay, because remember, the long side opposite the 60 is always the root of 3 times greater than the short side. Okay, here's a generalized one. Here's p, so this is p over 2, and this is p over 2 radical 3. That's the only thing we can do with that. Okay, I believe I wanted this to be a 5. So that's 5, that's 10, and this is 5 the root of 3. Here's a 30 here. So twice that side is the hypotenuse, which makes that 10 the square root of 21. And then the long side is the short side times radical 3. So that's 5 root 21 times radical 3, which looks like that would make that 5 root 63. And I guess 63 is 9 and 7. 9 and 7, isn't it? Yeah. So that's 5 times root 9 times 7, which is 15 root 7. Let's wrap it up. Okay, a couple more down here. Okay, so you got to go through Pythagoras here. So that's going to be what? The square root of 400 minus 36. So you can figure that. This, of course, you got to go through Pythagoras and just say, well, what? It's 81 minus 2 root of 3 squared, which is 12. Okay, so it looks like x is going to equal what? Square root of 69. Okay, 5 root 7, and this is a identified as a isosceles, right? So this is 5 root 7. And then the hypotenuse is the root 2 times larger than that, so that's 5 root 14. Okay, wrap it up. Last couple here, all right? Got to go through Pythagoras. So it gives us 25 squared minus 7 squared is equal to the x length over here. Okay, so you can figure that out. This is, generally speaking, this is s. This would be s root 2. It's just a general example. This is root 2, okay, and this is 1. So we go through Pythagoras and say x is equal to the square root of 1 squared plus the square root of 2 squared, which is going to be, x is going to be equal to the square root of 3. So there you have every problem worked out in its entirety inside of 11 minutes, okay? Right, so you can check them now.